Welcome to The Explainer. Today, we're diving into a pretty radical idea, one that could totally change how we build for the cloud. What if the real secret to faster, safer apps wasn't about adding more features, but about, well, taking almost everything away? So let me start with a question for you. When you launch an app in the cloud, do you ever stop to think about the massive, invisible foundation of software it's sitting on? Is it possible that your super sleek, modern application is actually hauling around a ton of unnecessary baggage? Well, the answer is almost always a big yes.
All right, so let's really get into this problem. Most of our applications today live on general-purpose operating systems, like Linux. And hey, they're powerful, they're super flexible, but they're also built to be a jack of all trades. And that creates this huge, hidden burden for your app that's really only trying to do one thing.
And when you look at it side by side, the contrast it's just wild. A typical OS is loaded with stuff from multiple users, a gigantic library of hardware drivers for things you'll never use, complex shells, even graphical interfaces. But what does a modern cloud service actually need? Honestly, it just needs to run its own logic, talk to the network, and maybe access some storage. That's pretty much it.
And here's the kicker. This isn't just about being inefficient or wasting space. Every single one of those unused libraries and utilities is another potential door for an attacker to walk through. It's really simple. The more complex the OS, the larger the attack surface. Plain and simple.
But what if we could just flip this whole model on its head? Instead of taking this bloated do-everything OS and trying to carve bits out of it, what if we built a brand new one from scratch, one that's perfectly and precisely tailored for just one single job?
And that, my friends, brings us to the unikernel. Now, you should think of it less like a traditional operating system and more like a custom-built life support system for just one application. It's this specialized, single-purpose package that has only what the app absolutely needs to run and nothing else.
And this is not just some academic theory. Nope, projects like Stardust are building these systems right now. The real key here is that phrase, single address space. By getting rid of the boundary between the app and the OS, the whole design gets way simpler, much more efficient, and a whole lot more secure.
So how in the world do you actually build one of these ultra-specialized systems? Well, the magic happens in a process that basically fuses the app and its OS into a single, seamless unit before it even boots up.
The core technique behind all of this is called static linking. See, normally when an app starts, it has to go out and look for all the libraries it needs. With static linking, all of those pieces are baked right into one complete package from the very beginning. There's no searching required. Everything it needs is already there.
And the build process itself is just beautifully logical. First, you start with your application's code. Then, you select only the specific libraries that it actually uses, nothing extra. You combine that with the absolute bare minimum kernel functions needed to run. And finally, you package the whole thing into what's called an immutable virtual machine. It's sealed, it's tamper-proof, and it is ready to go.
Now, this whole approach might sound a little out there, I get it, but the payoff is enormous. Let's take a look at the incredible advantages that come from being this lightweight and this focused.
The benefits here are just huge. A tiny code base is way easier to check for bugs and to secure. The fact that it's self-contained makes it incredibly portable. And with no extra layers or context switching going on, you get extremely low latency. What does that mean? In short, your application just runs much, much faster.
Okay, that all sounds great in theory, right? But what does this actually mean for us in the real world? It means unikernels are a perfect match for the cutting edge of cloud architecture.
They are tailor-made for the modern cloud. Think about serverless computing, Lambda functions, where you need things to spin up in milliseconds. A unikernel is perfect for that. Or what about microservices, where complex apps are built from hundreds of tiny independent parts. Each one of those parts could be its own tiny, secure, and absolutely blazing fast unikernel.
And this whole idea isn't just standing still either. It's an active field of research that's constantly evolving, using the latest tools and the newest programming languages to get even more powerful and even more secure.
So you have developers right now who are taking these core ideas and rebuilding them from the ground up in modern languages that are specifically designed for safety and performance, really pushing the boundaries of what's even possible.
And this is a fantastic example of that. The original Stardust project was built in C, but now there's a new project called Stardust-Oxide, and it's a complete re-implementation in Rust,
a language that is famous for preventing all sorts of common security bugs right from the get-go. So it's the same great idea, just made even safer.
So we'll leave you with this thought to chew on. As we look to the future of computing, maybe, just maybe, the next great leap forward won't come from adding more stuff, but from the radical simplicity of building with less. Thanks for watching.